Fix the track tensioners, they said. It'll be easy, they said. Oh, hey there. Welcome back to Farmcraft. I'm John, and this is a big spring. So this is on the track tension mechanism on my big excavator, and let's review real quick how we got here. I bought this old excavator for scrap price, and I've been doing a lot of work on it trying to put it back into service on my farm. After a whole string of repairs, when I finally got to tensioning the tracks, of course the seals were blown out, so I was going to need to replace the seals. Well, that leads to splitting the track, which turned out to be very difficult on this machine. Usually you can do it with a big sledgehammer, but that was no go on this one. So I ended up welding together a contraption to push the spring out using a 50-ton bottle jack, which did work and led me to making a pin press that I can use in the future and also use on the other track on this machine. But when I removed the tensioner, the grease cylinder, I found that the spring pretension rod on both sides was broken. I went through the explanation of what these pretension rods do in a previous video. I'll link to that if you're interested. I'm not going to go through that again. So in the last video, I was trying to torque this bolt down in here to compress this spring. And I ended up breaking my 3/4 inch breaker bar, which really didn't surprise me with how hard I was pushing on it. But I did not expect the torque to be that high because I'm only compressed 1.5 inches at this point. And by the way, I did grease the washer at the bolt head before doing this, but I forgot to put it in the edit. What I need to do now is get these compressed, I'd say at least 3 inches. It looks like they were compressed just over 4 inches based on my measurements, but it's possible when those rods broke, they stretched a little bit. So I don't think I need to get to 4. If I get to 3 inches, I'm good. And that's based on the fact that the spring compressed 1.5 inches when I had it properly tensioned. So 3 inches will be more than enough compression to make this a rigid structure for the grease cylinder to push against. Now, springs this big are dangerous when you try to compress them, and people have been killed trying to do that. And I did not go into this just sort of willy-nilly blind and assume everything's going to be okay. I put a lot of thought to this. My brother-in-law is an engineer. I talked to him about it at length and came up with a plan that I think is reasonable to pre-tension these springs myself. That's what we're going to do in this video. Hopefully get this fixed up. Rightfully so, some people in the audience were concerned about my safety because if something were to break and this spring lets go forcefully, well, there's a lot of force in there. The question is, how much force is on this spring? Well, there's free online calculators to figure out things like this. For a simple coil spring, if you have some basic information like what's the outer diameter, the inner diameter, and some other things at the length, it will give you a spring constant, which comes out to 12,416 pounds per inch of compression. So in order to squeeze that spring 1 inch, you need to apply 12,400 pounds of force. To squeeze it 2 inches, you need double that. And 3 inches, you need triple that. It's a simple coil spring. It's a linear relationship. As close as I could measure it, the length that it was at the factory would require 51,000 pounds of force to compress it. To properly tension the track, I need at least 1.5 inches of compression. So I want to get more than 1.5. I'd say at least 2. 3 sounds really good to me. So 3 is really my target, and that requires 37,000 pounds of force to compress that spring. Several people said use the log splitter that you have for your excavator, but it's not anywhere near wide enough. The opening isn't nearly wide enough for this spring. And that would get kind of dicey. I'd have to do a lot of work to have it safely held in there. The other thing is a lot of people were saying just use the thumb and the bucket. It's not strong enough. If I really wanted to go to where it was, that would be 51,000. I can't generate that much force, even with large marge in the thumb. I have the same issue with using the bucket to push down against the spring. 37,000 pounds is more than half the weight of the machine, but I think I could compress it more than I was able to with the bolt. The problem is I don't think that's very safe. The controls on the excavator are pretty coarse. You move the joystick a little bit and it will move a lot. And I'd worry that I'd over-compress that spring and then something would slip and it'd come flying out of there very dangerously. So I don't want to do that. Now, obviously, I could build a cage. There's a lot of different ways I could do this. So I know folks are going to ask why I don't just use the shop press. You know, this will compress 20 tons. That would do an awful lot on this, maybe not the whole thing. Well, the answer is it's not tall enough. My spring assembly is 40 and a half. The maximum that I could do on this press is about 31.5 inches. And it's not strong enough. I think there's going to be a better way. We'll get into that later. Let's just say I need 37,000 pounds of force to compress this spring. And I did a calculator. It just surprised me how much torque it was requiring. Many of the calculators were saying that I would need around 1,100 foot-pounds of torque, maybe 1,400 foot-pounds. Well, when you've got a 6 or 8 foot extension, you can actually generate that much just by hand. But I didn't even get close to 3 or 4 inches of compression and broke the bar. So I think I'm getting more friction on my cut threads that had a lot of chatter in them when I was cutting them than I was anticipating. And that's something that many people pointed out. Good quality bolts are rolled threads. They're almost forged into shape in a factory by these huge machines. They're not cut on a lathe, certainly not on a small lathe like mine that's going to chatter and lead to some irregularities in those threads. I have to machine the bolt for the other side, which we're going to do in this video. You guys made some great suggestions on machining. We'll get into those later. I'm going to do things a little differently on this, so that'll be some interesting content, seeing different ways of doing the same thing and maybe doing it better. So the other thing is, how safe am I with what I'm doing? Well, I'm using 4140 steel, and it is in an annealed state. It's not hardened or tempered, and that's fine. I don't want to try to heat treat it myself and have it get too brittle and snap. That would be a bad idea. It's strong enough in its annealed state to do what I need it to do. So the yield strength of 4140 is 60,000 psi. The breaking strength, the tensile strength, is 95,000 psi. That's pounds per square inch. That means if I had a bar that was just 1 square inch, it would be able to hold 60,000 pounds without yielding and 95,000 pounds before it broke. This is a 2-inch bolt, and even accounting for the narrowest part, like when I make a relief cut for the threads, it comes down to 1.9. Take 1.9, divide it by 2, pi r squared, get the area. It comes out to 2.5 square inches of area in this bolt, in my weakest point. Multiply that by the yield, psi, that's 152,000 pounds before it's going to yield. It's 240,000 pounds before it's going to break. And my thread engagement, even though my threads aren't perfect, there's plenty of thread engagement there. It's 12 threads per inch, and that means for every inch of depth, I've spiraled around that diameter 12 times. There's a certain area for every turn that the threads are overlapping. And that is essentially your surface area that makes the strength of those threads, how they're holding on to each other. Well, when you multiply that by 24, because you've got 24 wraps of thread engagement, this thing is 2 inches thick, it actually came out to almost 5 square inches, more than this. And a rule of thumb is for threads to be just as strong as the bolt that they're on, you need equal thread engagement to the diameter. So I've got a 2-inch diameter, I need 2 inches of threads, and now the threads are just as strong as the bar. That's just a quick and dirty rule of thumb. Fact of the matter is, especially if I'm only going to 37,000 pounds, look at these numbers. This thing isn't going to yield until 150. That's a safety factor of more than 4, or about 4. And breaking strength, it's like 7. I can't do the math, but anyway. This bolt is plenty strong for what I'm doing with this spring. And this is the main reason that I feel safe doing this. I'm just going to make sure that I don't over compress the spring and allow it to hammer onto the bolt with any significant distance. In other words, if I compress it a small amount and then tighten the bolt, compress a little more, tighten the bolt, there's just no way that the spring is going to damage this bolt. All right, so let's get back to work here. Where it stands now, I have one of these springs compressed to 39 inches, which is not as much as I wanted, but probably would work. And the other spring is still in pieces, so I'm going to start out making the nuts for that one. This is a piece of hex stock that I drilled in the last video, but it still needs to be threaded. This will form the bolt head when it's all done. Okay, threading my second nut. I'm going to thread this one towards the chuck. Because I have my new threading tool, which is right-handed, I can't easily go the other way. I'd have to go upside down, and I just haven't had good luck doing that. But because this is more rigid, I have plenty of room. I can stick it out, and I should be able to make a good thread and still have room to stop before I crash into the chuck. I'm going to touch off, we'll do a scratch pass, and then I'm going to thread this thing 50 thousandths deep. There it is. Let me zero everything. Okay, 0, 0, 0. We're ready for a scratch pass. Okay. And even though I haven't changed the gears, I can't help it. I have to check with the thread gauge because you just don't want to get that wrong. Looks perfect. Having the right tool for the job sure is nice. This thing is cutting so much better than that high-speed steel was. Alright, pretty nice looking thread. I had one mishap on a spring pass where I accidentally disengaged in the middle and I messed it up there, but this is the bolt head. I've since cleaned up the thread. It'll thread on and then get welded, so it's fine. Man, I'm an idiot. So I think my carbide cutter is really struggling here, but I'm about to get to those threads, so I'd really like to do that before I change it out. I'm going to take this out and see if I can't unscrew it at this point, because there's just not much left in there. See, I'm back here boring through this thing. Guess I could cut that off at the very least. Well, it's bending it. Well, not really what I was hoping for, but at least I got all that excess off the back. In retrospect, I probably should have cut that off before I even started, instead of spending all that time drilling and boring through it. Right in the threads now. That's what I didn't want to do to a brand new insert. Oh wow. Alright, now I'm going going to do one more pass with this insert and I should be good to change to a new one. I don't have too much further to go, so I'm going to do light cuts here. So you guys remember in the last video when I was trying to thread a nut just like this, I want the compound arranged this way so that I can pull and cut on the leading edge, but I can't do that because this is going to interfere with the compound. Well, several people in the audience who know some tricks that I don't apparently had a great suggestion that I've just never really thought about before, and that is to turn the compound around. I need that angle, but the compound interferes and I hit the cross slide because the tool post is held all the way over here. When the compound is this way, the tool post is much closer to the work and the cross slide is no longer a factor. So how do I get that angle? Well, how about that? So I've never thought about using the compound that way before, but there's no reason you can't. That'll work just fine. Gets the compound out of my way, gives me the angle that I want. That's perfect. Actually, I'm going to put a little chamfer on that before I start. Now, I'm nowhere near engaging the work, so I'm going to just do a dry run, just make sure everything's going to go okay. You say I was ready to cut. That is going way too fast. I need to be on 220 RPM. That's better. I'm cutting. Yep, came out. So then I will advance this, come out of the work, come back to 0, dial in my cut, and go again. Alright, easy peasy. So let's touch off and 0 everything. There, I just touched. Alright, so first cut, I'm going to dial in. Let's do like 8. Did about 8 more. Calling it good. Alright, so I got my nuts. 2 of them, in fact. Imagine that. Now we're ready to start on the bolt head. Well, that doesn't make much sense. That is the bolt head. But I'm ready to thread the end of the bolt that this is going to thread onto to make the bolt head. You know what I meant. Yeah, I've been here quite a while doing these measurements, and I've got this as close as I can get it. It's not an easy thing to measure. I've got it as close as I can. Let's put a center drill in it, and I'm going to do something different than I did last time. Now I got a good live center in there. So this is what I'm going to do different. The last time I kind of forgot about this. I really should have. While this thing is almost perfectly round, it's probably not perfect, and I'm also not perfectly concentric. So trying to stabilize it with a steady rest the whole time I'm threading, running on something that's not perfectly true, is going to lead to things like chatter like I got last time. So I'm going to do what you're supposed to do with a steady rest. I am going to machine just enough off of that so that I have a perfectly concentric area to put the steady rest on and really have a good hold on this thing while I'm threading. Hear that intermittent cut? That's what I want to get rid of. So the button insert's a nice idea because of the radius, but I think it's going to chatter too much. Cut very nicely, so I've got a good concentric area for the steady rest now. And I am going to go ahead and try to radius the edges. That little radius there will prevent stress points long term. Now we snug up the fingers, locking everything in. Now I'm going to make a groove and then file it like I did the last time to have a place to exit my thread. And I'm actually not running as true on this one as I was on the last one. I think it's about 8 thousandths or something. To still be in spec for the thread, I actually do have some room to take off of this. I'm measuring 1.996. 1.987 is the minimum diameter for a 2A thread. So I'm going to go ahead and turn down to that and get that as concentric as I can. Alright, you can see there's just a little spot that I haven't quite gotten. That's still within spec. Obviously it's not perfect because of that, but we're probably talking about 1,000th or 2. This is the bolt head end. These threads have some leeway. In fact, you know, some people would just weld this thing and not do the threads at all. The last threading tool I had was kind of a cheapo one that came with a carbide set, and I wasn't impressed with it. So this is a freshly ground high-speed steel, and it actually has a positive cutting angle. I want to try this. Let's see how this does. I am going to touch off. I'm going to zero my cross slide. I'm going to zero my dial indicator. We'll do the scratch pass. Make sure we're at 12 TPI. Then we're ready to thread. You guys have seen this before. The question here is a high-speed steel cutter with a good solid steady rest and everything set up like it is it going to chatter? Is it going to do a good thread, or am I going to need to come up with something else for the other side? I just touched. I'm going to advance another thou, and then we'll zero. Okay. Yep, that's 12. high-speed steel is not loving it. Let's go to 70 and see how it does. It just seems too darn slow. It's cutting. Alright, I'm going to do a spring pass and then we're going to check it. So I've come out with the cross slide, and that's where I'm going to leave it so I can get this out of the way while I'm checking the fit. You got to remember where you are. Starting, but it's pretty snug. Well, I went a little further than I wanted, but I mean, that's a pretty good thread. And will certainly work for a bolt head. This did answer a question for me. Even with everything that I did, I was still getting some chatter in cutting that thread, and I can actually see it. It looks, you know, pretty darn good, and for most threads it would be fine, but given that I'm trying to crank this thing down, I'm kind of experimenting here. I have a plan B, but I still want to see if I can get threads that will perform better than my first attempt. Yeah, cutting it with high-speed steel, not the answer. I think I need a better thread cutter. So unbeknownst to me, I am heading into probably the worst machining experience I've ever had. I'm going to share all the details and you can pay attention and see where I screw up. This is going to be painful to edit. I have to live through this horror all over again. Alright, I've got it flipped around, centered, center drilled, faced off, chamfered, and the steady rest is in a good position. It's all ready to thread, except I need a new threading tool. And it is on order. So, brand new indexable thread cutting tool, carbide. So that's actually got a positive rake angle, meaning it's tipping up into the cut a little bit. It's not just flat, and that's good quality carbide. That should do a nice job on this 4140. Alright, so first thing I'm going to do is machine this down to perfectly concentric. So I have to be careful and take really light cuts here. I need most of the diameter of this bar, and I'm trying to stay within specs for a 2A grade thread. So you can see I'm getting an intermittent cut, but then right around here it is not cutting at all. So there's a slight bend in this bar on the order of thousandths of an inch. So I'm measuring 1.995. I can take 8 more. Let's do a 5 cut and see how we look. You can hear and probably see it's still an intermittent cut right here. So the interrupted cut just went away right there. Interesting, it doesn't look interrupted anymore. That's kind of the lower end. I could take 1,000th or 2 more, but that's the lower end of where I want to be. So I think I'm going to go with that. We're going to go at 220. Let's touch off and do a scratch pass. Go. cuts nice. I can already tell a difference, I think. And that's what you'd expect. It's carbide, it's not high-speed steel. So I felt like I could hear a hint of it wanting to chatter there. So I'm going to do light cuts, 3/1000ths a pass, and I'm going to use lube from here on out. Still have a touch of chatter in there. It's still better than the high-speed steel was. It took that entire cut as one chip. I still hear it chattering a little bit. So I am going to go to 70 RPM and we'll see what that does. Yeah, I think that's doing better. I don't hear any chatter at all. Let's check it. Trying to start, but not quite there. So looking at my dial indicator, I started at 0 and I've come around to 62. So I'm actually it's 58. I'm 42.5 into the cut. I'm going to do like another 5, and then we're going to check that again. And I'm going to spring past that, and then we're going to check it. So I'm not advancing the cut at all. We're just going to do that exact same cut again. Well, it went on. Still a touch snug. So even though I hear a touch of chatter, I don't see any chatter. It's definitely better than the high-speed steel, no surprise. I might even just do another spring pass and file them a touch and see, ow! And see if this will fit again. Oh, that hurt. Forgot how heavy that darn thing was. So I don't want to overcut these threads. The more you take out of them, the less overlap there is, and the less they can hold. Remember, this thread is going to be responsible for holding back all the pushing force of that huge spring. Still just a touch snug. I just dialed in about 2.5 thou. I tested it again, but still a little too tight. That's the air compressor that kicked on and ruined the audio. Actually, it might have saved me from having to edit out some 4-letter words. It's threading on just fine. It has very little play in it, very little resistance, feels really good. Until right here, I felt a little clunk and suddenly it got harder to turn. So this is really frustrating. I was hand threading it on just to check the fit, and I felt something like a chip got wedged in there, and now I can't get it off. And it's requiring an absurd amount of force to even try to get it off. Sure, I'm going to be screwing up the threads, but I don't have any choice here. I've got to get it off. Good grief. And the thing won't go in either direction now. In case you missed that, that just broke the chuck key, which I'm using to hold the spindle still while I'm trying to turn this thing off. Well, this lathe doesn't have any good way to lock the spindle, so I've got a bar right here between the spindle and the lathe bed, so it can't turn this direction. And now the whole thing is spinning in the chuck. Unbelievable. I threaded this thing on by hand, and it just got stuck, and now it is permanently on. I'm just taking the soft jaws out. I'm not worried about it being indicated in. I'm just going to crank this chuck down as tight as it will go and hopefully unscrew that thing. I don't know, man. Threaded it on by hand. Remember that. I bent the rod. Nice. Man. I mean, I've never even heard of anything like this. Threaded this thing on by hand, and it is totally stuck. And I have tried the other direction as well. It's moving. I'm just picturing what I'm doing to the threads now in there. I'm probably completely destroying them. Hopefully not in this, because once it's compressed down, I'm going to be up on these threads here, which are still okay. But if the nut is ruined, well, I'm going to have to make a new nut. It's unbelievable. All right, good morning. I had to step away. I've never even heard of something like this happening. Hand threading something on and getting it hopelessly stuck. I'm just wondering if this stuff doesn't seem quite as lubricating as a cutting oil does, especially for something like this. It does a good job when you're cutting, but for testing a nut, I'm wondering if cutting oil wouldn't have given me a little bit more leeway. In fact, I think when I was threading it on, I could hear it squeaking a little bit. In retrospect, I should have put some oil on it. I've been spraying this down with penetrating oil. This is one of the few cases where I think penetrating oil actually has a chance of getting into the threads because they're not hopelessly rusted together. There are areas that it can get in there. And I've got a wood block over here holding the chuck jaws against the ways. Shouldn't hurt anything. The spindle is locked and I should be able to push this thing both ways and hopefully work it loose. We shall see. The last thing I did was try to loosen it, so I'm going to try to tighten it here. And if you're wondering, there's a little step in the nut. That's what I'm using the chain wrench on. The chain is not long enough to go around the outer diameter. I hear that piece of wood breaking. That's what that did to my piece of wood. So you can see here what I'm trying to do. Lock those chuck jaws, but the jaw out at the end doesn't have a whole lot of surface area that it's going to impact on that wood. This is a piece of oak. I don't really want to use steel because it's down against the ways, so the oak protects the ways, but obviously it gives. Alright, I went up to the wood shop and just routed out where the chuck was, so that allows me to get all the way to the center of the board where it's really going to be pushing. Oh man. That is absolutely insane. Alright, I think I got it. I got a plate on top. Still doesn't have a lot, so I got this piece of scrap that goes. So now I'm catching this jaw and right there. Ooh, it just moved. And a little bit again. That's something. Let's get some penetrating oil on there. I can't believe this thing is this stuck. I mean, it just feels like I hit a wall there. .212. The bolt. It's getting hot too, unfortunately. Maybe it made the penetrating oil go in there further. Alright guys, I've been at this for a while, and I'm starting to think this might be a total loss. I may have to cut this thing off and drill it out. I can't believe it, but I have heated this very hot. I've not quenched, but cooled the bar to keep the temperature gradient as much as possible. I've used an extension on this that's 5 feet long and hung my body off of it. So we're talking about 1,000 foot-pounds I'm putting on my lathe, which I don't really like. I've made no progress. Both ways, it's like I'm hitting a brick wall. I guess I'm going to step away for a little while and think on it. I wish I knew a good machinist that I could bounce this off of to see if they have any ideas. I actually end up posting this on my Patreon page as well as an online machinist forum. I got a lot of good feedback. I may not have liked the answers, but those folks were very helpful. Thank you. So I've been asking around, and I think this part is scrap. I don't think I'm going to be using this when I'm threading anymore. Machinists are saying that you have to oil the threads before you test fit the nut, and this is water-based, so it just doesn't, it's not putting a film of oil on the metal. So they essentially cold welded and then galled the threads. Now it's toast. The question is, can I save the nut? Believe it or not, the bolt is easier for me to buy. I mean, that's just a piece of 2-inch 4140, 34 inches long. This is a piece of 2-inch plate with the step machined out of it and then threaded. The nut is more difficult. I have one last ditch effort I'm going to do. So I've got it held vertically in a 3-jaw. I left the nut in the middle of that loose position before I tried this, hoping that the oil could penetrate. Alright, that has been sitting there for hours, and not a drop has come through the bottom. That's actually impressive that that thing is, I don't want to say watertight, it's penetrating oil tight. One of my patrons suggested I try a mixture of acetone and ATF, so I'm going to mix some of that up, we're going to fill that up, and I'm going to let that sit there all night and just see if anything gets through. It's much thinner, so hopefully it will be able to penetrate better. And just because that acetone is going to all want to evaporate, I'm going to wrap this in a trash bag. And we're going to let that sit overnight. See you tomorrow. So it's the next morning, and Nothing got through. That's crazy. Because that acetone made that really thin, and you would really think that it would at least drip a little bit through. I mean, it's not like those threads are all packed full of rust. Which, by the way, people are always asking me why I don't use more penetrating oil. I just never find it to help. Not when it's an old rusted on bolt. The oil just doesn't get in there. I mean, these are brand new threads, galled in one spot, and it won't even get through that. How's it going to get through? Especially when all you're doing is spraying the bolt head. It's not even getting to the shaft. I mean, here I've got a little well that I'm pouring it into, and it's sitting there collecting for hours, and it's still not getting in, or at least not getting through. It's probably getting in some. Anyway, I don't use a lot of penetrating oil because unless the bolt is moving, I find it does very little, if anything at all. Before I make a final decision on what to do with this, I want to go to the first spring that I already torqued most of the way down. All right, here's the answer to the big question. I'm going to use the pin press to compress this thing. This is really the perfect tool for the job. The only problem I had was the threads weren't long enough. I got 3 6-foot rods. They took a very long time to get, but they're finally here. These are grade B7, which is similar to or maybe a grade 5, but done the engineering on it. Those 3 rods are stronger than the jack. And the jack is way stronger than what I need for the spring. I only need 37,000 pounds. So the safety factor in this is multiple times. I shouldn't have an issue. The big question is, how are these threads holding up? Given what happened with my other threads, now these were oiled. There's no reason that they should have cold welded and galled together, but there is a concern that, boy, that would stink if they were stuck too. Let me figure out how I'm gonna get this thing arranged. Around this, I'm going to have the jack here pushing through a hollow pipe so the bolt has a place to go. And then as I compress the spring, I'm going to be able to measure, and I'll compress like 1/8 of an inch and then tighten the bolt. 1/8 of an inch, tighten the bolt, and just step my way along, very controlled. There's never going to be a chance for the spring to really go any distance because the bolt's always going to be there ready to catch. So I feel like this is definitely the safest option. Trying to compress it with the bucket or the thumb. 1/2 inch of compression on this thing is a heck of a lot of force that then I have to control and run over there and tighten the bolt. It just seems dangerous. What if I compressed it 2 inches? Or what if I compressed it 4 inches? Because the controls are very coarse. I feel like this is a much safer way to go. So here I'm putting the socket on the bolt head, which is down inside this collar. All right, so the big socket's all the way on. That socket sticks out from here. And this plate needs to be all the way up to that, which means this socket needs to fit through that hole. And it does not. So I'm gonna go machine that out a little bit more. We are at the moment of truth. The first thing I'm going to do is just compress it a little bit, and gosh, I hope those threads aren't galled together. After that last one, I'm feeling a little gun shy on this, but what are you going to do? Let's compress it down and see what happens. So I'm just going to compress it like 1/8 of an inch, and then I'm actually going to try to back off of the bolt a little bit and see if I can't get some grease on it. It's going about 1/16 now. Yeah, so one thing I like about this, doing it manually, is I can feel how much pressure I'm putting on it. And really, it's pretty easy to pump right now. So I put way more pressure on this system when I was pushing the pin out, using it as a pin press. So there's not that much going on right now. The question is, can I spin this bolt? I mean, it moved a little bit, not a lot. I do think I ought to go ahead and spin it most of the way out. At this point, my plan was to completely remove the bolt and then grease it with molybdenum disulfide, which is what I'm applying right now to the little bit of threads that are sticking all the way through the plate before I unscrew it. So I got everything set up again and compressed the spring again, and then tried unscrewing and didn't have as much luck. If at first you don't succeed, try the exact same thing again and continue to have no luck. Yeah, I have now compressed it ½ an inch. This won't be that bad. I just gotta make a couple big bolts. That'll be fun. The bolt was barely moving back and forth, so I'm greasing the threads that I can reach. This is starting to feel a little bit like deja vu. It would be really nice if I could heat this nut up and then unscrew this thing. I mean, after all this, I deserve one thing to go right. Come on. And of course the answer is it didn't budge. Man, I am learning stuff the hard way with this repair. Good grief. So these threads are all jacked up too. I'm going to be very careful about 4140 threads in the future. Or maybe it's just big bolt threads, I don't know. I've never had a problem with threads like this before. Anyway, recall that this spring was pretty much compressed to where I needed it to be. I wanted to get a little further, but it was not bad, and it still is not bad. So I think I'm gonna cut my losses on this one. I'm gonna go ahead and tighten that bolt down as tight as I can get it, and we're gonna call it good. This side's done. The other side that's still stuck on the bolt, I've got a plan for that, I think. I'm pretty happy with the safety of this spring compressor. So I have a plan on actually being able to salvage the parts that are there. We'll see if that works. But for now, let me just get this bolt tightened down as tight as I can get it, and we're gonna call this one done. We're gonna put some foot-pounds on that thing. I've got to hold it in position to use the breaker bar, otherwise the whole thing would just rotate. So that excavator is levitating. The weight is on the blade and the bucket. So half the weight of the machine is right there on that thing. Well, I've got 8 foot of lever arm here. And that's all she's got. That's all I'm getting out of that thing. Goodness gracious. All right, that one's done, sort of. I'm calling it done. I wish it was better, but it is not worth the work at this point. It is definitely good enough for this old farm machine. Sometimes even I know when to pick my battles, and this is not one. So the question is, what about that other one in there? So my plan when I was starting machining the second one, before I knew about the thread galling issue, was I was going to make these threads really nice, lower chatter than the first set. I was actually going to put some polishing compound on it and run the nut back and forth and really smooth the threads out, get them really good. And then I was going to lube it with molybdenum disulfide. It's the best at reducing the friction when you're torquing it down. And then I was going to try torquing it again and see if I could do it, see if it would work. But now that I know what I know about 4140 and threads, that is off the table. So here's the deal. I've got a little less than 3 inches of it threaded in. That means potentially I could cut all of that off, compress the spring in my pin press, and then I'd have enough threads to fully engage the nut, assuming I can save the nut, and have the spring properly compressed doing all of the compression with the pin press, not using the threads. I guess in retrospect it was stupid to think that I would be able to use these threads to compress that spring. I don't know, it's kind of strange to me because the max torque on a bolt like this size, this thread pitch, is like 4,000 foot-pounds. And I calculated, well, I was going to need like 1,200 foot-pounds to compress that spring. So I thought, oh, the threads will be able to do it easily. My real fatal flaw was I did not know that 4140 is notorious for thread galling. I was not aware of that. Google it. It's all over the place. I think I would have been better off to do like 1045 steel, or maybe I think it's 1144. It's free machining. They're not quite as strong as 4140, but strong enough for this application, and known to machine better and not have the thread galling issues nearly as often. That's a lesson I'll never forget. Let's just put it that way. My goal right now is to see if maybe I can unscrew this thing a little bit further after having let it sit in penetrating oil for basically 2 days. Every little bit more that I can get is going to make doing the spring compression thing that much safer. I won't have to compress the spring all the way down before I can start threading the bolt in to act as kind of a safety backup. That's my plan at the moment. If I can't get it to unscrew, I'm going to take this off and then start machining in. Maybe I can just like take the bolt out halfway through and maybe then it'll thread off. I don't know where the galling is. You know, it could be here as opposed to all the way over here. So I should say this has been a pretty painful process for me. I feel like I'm spinning my wheels and not getting anywhere, but you know, the reality is I've learned a hard lesson about 4140. That's a good thing. I won't make that mistake in the future. I've also, at times I've wanted a way to lock my spindle, so I've built that. I've got a pin press, and a pin press that I can use as a different, like a shop press. So I've gained a lot out of this. It's not a total loss, but these are some painful lessons to learn, let me just say. Yeah, when I was soaking it, I left it in the middle of this loose spot. It does not feel any different. I don't think this thing is going to unthread at all. It's moving a little bit. Every little bit I can get helps, because that's just making the bolt that much longer. Let's add some heat to the equation. Will she move? That's a negative. Yeah, that is 5 feet long. I'm 200 pounds. That's 1,000 foot-pounds. That chain wrench is amazingly not exploding. I'm not pushing it any further. That's going to be it. Let's work on getting that bolt out of there. I don't really have room to drill it. I'm right at the end of the ways, and you put a chuck in there. I mean, I can back this up a little bit, enough to center drill, but I can't use any regular bits. It's too long. So I can't drill it out, and this hits the cross slide. So you say, oh, we'll just move the carriage past it. Well, I've only got 4.5 more inches of travel on the carriage. So it would need to get all the way to, looks like 6.5 inches just to clear. And then I wouldn't have any ability to go back and forth. So there's no way I can get the cross slide on the other side of this plate. Even with the compound like this, I can't get far enough out. There's no way to get a tool that can reach around that. Trying to do the old reach around, can't even do that. But you guys might remember when I made a certain tool for a different job on this lathe. It might just work here. So now with this 1-inch boring bar, now I can do the old reach around. All right, two problems here. First and foremost, you can see the apprentice marks of when I made this thing. So just don't look at that. But the real problem is it's hitting the steady rest. I need to rotate this way to get away from this, but I can't because the steady rest is there, and obviously the further I get away with the steady rest, the less support I have. I left this long, not really sure if it was going to be useful to me. I don't think it's necessary. I don't think it's helping me very much. I'm going to cut it off right there. On second thought, I'm going to be able to machine all of this off, and I was thinking maybe I'd be able to drill some, but there's just not enough room. So I'd have to use a mag drill. Well, the biggest bit I can do on the mag drill is 1 1/8 inches. This being 2 inches, that's not going to make any difference. I have no way of boring it out because this plate's too big. So this is kind of a waste of time. So let's go to plan D, F, H. And since I'm here, I'm going to go ahead and face off and chamfer. That's all I'm going to be able to do, though. Remember, these threads probably need some more work, but we're going to have to come back to that later. I need a nut. Now, a quick chamfer. You guys missed the chamfer because the battery died, but it really wasn't that exciting. And there you can kind of get the idea. The bolt is still longer than it needs to be. Obviously the threads on the old one broke off. This is still longer than the old bolt was new. So if I actually grab this thing by that, I can drill most of it out and then have a handle to try and unscrew it. Because if I come from this side and grab it there, then all this goes away and I'm not going to have anything to try to hold on to try to unscrew after I've drilled most of it out, if that makes any sense. I actually changed over to my 3-jaw chuck because there's nothing out here for me to indicate on to get it on center. So this will center it within a few thousandths. And then I used my dial indicator to get the face running as true as I could. It was within about 10 thou. Step one, I'm going to drill this thing out, and at first I'm going to drill all the way through. So that's a half, this is 1 inch, and it's 2-inch bar, so that will leave a 1/2 inch wall thickness. So I can go all the way through with this, and then after that, I'm not going to go all the way to the end. I want to leave a little bit of strength there so that I can try to unscrew this. Alright, now this guy's 1.25 inches. So that's all the deeper I want to drill with that one. I've got a dial indicator set so I know when to stop, and I'm going to bore that out. So I'm just going to get close. I don't want to actually hit the threads though. Getting pretty thin. Did it move or was it the wrench? It moved a little bit. It's locked up pretty good again. I think I'm going to put it back on the lathe, take one more small pass, and then I'm going to probably leave it on the lathe and see if I can unscrew it. Be exciting if that thing comes flying off of there, but I think I can do one more. moving a little bit. Worry that thing's going to come crashing off there and mess up my ways. Got a board there to kind of catch everything if stuff starts falling. I think that's what a galled thread looks like. Machinist Online described it as snowballs rolling up in your threads. And you can see, look how choppy that is. Yeah, no wonder those threads wouldn't move. What are the chances that this is going to go easy? But the way this job's gone so far, I'd say slim to none. Or what the best solution is here. Oh. Well, if it keeps doing that, that would be nice. It didn't. You can see how just totally chewed up those threads are. That is just amazing. Because remember, this is the one that I threaded on by hand. This all happened with me trying to take it off. And I barely was able to turn it at all when I was trying to take it off. There's also a lot of debris in the threads. Now what? Back on the lathe maybe. Taking skims until I get to the edge so that I can get in there with a pick. I think that's what I'm going to do. So I'm sure it's not visible, but I can feel ridges in there where the threads are pushing that out. That's probably the worst galling there is because it's all full of crud in the threads. Ooh, I definitely opened up some. There you can see that one line of thread that's opened up. But I'm still not to the thread tops. I'm just taking 4/1000ths each pass. Yeah, see how brittle it is now? Work hardened. You can see a lot of them look fine, but then like right here, it just got totally smashed. The top of that one's gone. Like, wow. It did a number. Pieces of stuff just sheared off and jammed in the threads. Wow, look at how chewed up that is. So I would say that is where it started, right in the center of the thread. So I was toast from the start. Alright, so how do you effectively chase these threads? What I mean by that is to be able to cut them again using the same mechanism that I did before on the lathe. I have to get everything lined up and then have the lathe bring the cutter through there and clean those threads up. Make sure your dials are all set to the right position to cut the same thread pitch, in this case 12 TPI. So this is the thread cutter. This is what actually cut the threads the first time in this nut. I need to get it in one of the grooves while the lathe is engaged with the lead screw with the thread chasing dial on one of the numbers, just like when we were threading it originally. With this thing engaged, I need the cutter to be perfectly seated in one of the threads, and the only way I can do that, this is now locked to the lead screw, I can't move the carriage. So this might be about impossible to show you. Right there, it is pointing at the top of the thread. It needs to be down in the valley. Yeah, I'm actually going to loosen the bolts on the tool holder, and that will allow me to move that back and forth slightly so that I can line it up with the valley. And then I will turn the cross slide to bring it towards me and seat it in that valley and get it in the right place. You actually can use the compound to do this side-to-side movement too. I didn't have to loosen the tool. This seems good. I'm going to move it out just a little bit so that it's not being held away from the tool holder. And we'll snug these. All right, I don't know how well I'm going to be able to film this. What I'm now doing is spinning it by hand. I've got it close, but some of the areas where it's really galled, it's pulling some stuff out of the bottom of the threads, but I'm not all the way to the bottom yet. I need to pull the cross slide closer to me to get all the way to the bottom. And the other thing is I'm going to use the threads as every time I pull it in, I can see it cutting a little harder on one side than the other because this isn't perfectly concentric with the way the threads were originally cut. So I will loosen and tighten the forejaw to get it closer and closer as I do this. So this is going to be very time consuming and tedious. I'm going to do a lot of it by hand. I am through the back. Can disengage, come out, come back to my 0, and I'm going to add a little more. Let's come in another 5 thousandths. And then we need to engage on a number right there. I did this by hand several times and adjusted the forejaw as well as the cutter to get the setup as close as possible to the way it originally was, and then I was finally confident enough to try some under power. Slow and steady. And I continued cutting, advancing with the cross slide, plunging into the thread, until I had all the galling removed. Here's the final cut. You can hear it still cutting slightly heavier on one side, but I got it pretty darn close. I think the nut will work. So that's probably a little bigger than it was, but the threads that it's going into are a little big, or at least they were. It's possible they would go together now. So now I need to test these threads. I'm obviously a little bit gun shy about this, but I didn't have oil on them before. This shouldn't be a problem. But I'm going to wire brush everything off of these threads, and then I'm going to oil them liberally with whale oil and a clean brush. I am confident that every bit of those threads has a good coat of oil on them. I gave the threads in the nut the same treatment, cleaned them off, and then oiled them with whale oil. So far it feels really good. full thread engagement, it's threading beautifully. I mean, there's a little bit of clearance, a little bit of play there, but not much. Well, I don't know if that qualifies as something going right in this repair, but I guess I'll take it. I don't have to do anything else to these threads. So this thing is ready, I just need a bolt head on it. So that means putting the bolt head on the other end. And I've got copper soft jaws on here and I'm not grabbing it very tight. Just enough to hold it. That's not going anywhere. It was no trouble, so I did a few more passes. That's definitely not going anywhere. Right, now I need to get that washer on there, but I've got a bunch of stuff sticking out from when I was putting 1,000 foot-pounds on it on the lathe. These are from the chuck jaws holding onto it, and it's slipping. I've been doing some figuring. I won't bore you with all the numbers. I need to compress 2 1/4 before the threads are even going to contact on the bolt, and 3 inches to get 3/4 of thread engagement. But I've got that big fat washer in there. I made it nice and fat because I expected I was going to be using that to torque this down, but I'm not doing that anymore. That washer has become a spacer. It doesn't need to be this giant thing. So I have mounted it on the lathe, and we are going to trim it down. It still has the angle on this face, so I'm going to maintain that, and I'm just going to basically take most of its thickness off so that it just fills that gap under the bolt. What that comes down to is when I have 2.5 inches of compression, I'll have 1/2 inch of thread engagement. That's when I'll thread in the bolt for the first time. When I get to 3.5, I'll have 1.5, and 4 inches, I'll have 2 inches of engagement. So 4 inches will be my target. I think that's pretty much how it was when I got it. The risky part is going to be getting the bolt threaded in for the first time, but I don't think it's going to be that risky. I'll just clean that up on the belt grinder and we're good to go. Okay, so this is propping the shaft of the bolt up. The threads are all the way down here, so they're not getting touched. They're held right in the center. And you can see how much compression I need in order to get those threads to start engaging. Except that this plate has a step on it, so it doesn't have to get quite to the end. Ice melting is falling onto the roof just above me, and gives you a little mini heart attack every time it happens. Okay, no time like the present. Fortunately, right now it feels like there's zero resistance on this thing. I'm at 39. Another inch. 38 3/4. Just get a look at it, make sure everything still looks nice and lined up. Looks perfectly straight. Don't see anything stupid. It's a lot to juggle alone. The socket's too far that way, so I've got to take the tension off and ship things over. Yay. $38.5. The ice falling is a nice addition to this somewhat tense moment. Thank you. We are at 38, so I should be able to get that bolt to thread in. Except the socket jammed against the wall, so I've got to back off a little bit. Now, how do I get that bolt to thread in? I'm going to compress a little more and then see if it's threading. All right, I cannot tell if it's in or not. What do I do about that? I can't see the end of the bolt while I'm trying to turn it at the same time. So I got my better half to come help me and watch what was going on with the end of the bolt while I'm trying to turn it. It would seem like the threads were about to engage, but then it would get stuck and I just couldn't turn it any further. And obviously I didn't want to try to force it. So now it doesn't want to thread in. I think what happened is I was compressing the spring. The socket bound against the plate and jammed the end of the threads and messed the threads up. So it won't go together. So we are gonna let all the tension off. I'm gonna take this end plate off and we're gonna look at the bolt. I may have missed recording that. The nut also looks fine, and I threaded the two together. They went right together, no problem. So clearly they're not lined up straight. Tell you what, I'm gonna put this the other way. This flat was down before, I'll put it up. Maybe that'll make a little difference. It is cockeyed 3/16. There's no way that's screwing in. That's my problem. I tightened this rod a 1/4 inch, and now when I measure, I'm getting the same measurement on both sides, and I can't really measure the bottom, but I think we're pretty parallel now. So back to 38 inches of compression. So I would line up the bolt with the nut, and then I would try to thread it in, and I tried this several times. I was spinning the bolt backwards so that I could feel the threads align, and then tried to thread it in, and every time, as soon as I tried to thread it in, it would immediately get stuck. I was starting to think this was an impossible task. Why won't you thread in? Well, it's official. I have had enough of this job. It won't thread in. I don't know why. I'm measuring exactly 38 inches off of that plate everywhere I measure. I mean, I registered off of that plate to within a few thousandths when I threaded it. So I know the threads are parallel to this face, and that face is measuring parallel to this. Under all this tension, it's possible that this plate needs to go that way a little bit or that way a little bit. How would I know? So the only thing I can think to do, and this is the answer, take the pressure off, take the darn spring out, and then thread it in and see which way this needs to sit so that I can get it lined up absolutely perfectly. I don't understand why this is so difficult. This shouldn't be that hard. Grief. Working me to death. Yeah, that's what it's doing. Didn't want to thread in. I don't think that was apparent on camera, but the plate had to shift slightly in order to thread in. Don't know where we left off. Had a little cowl situation there. So I've got this labeled, this is up, and I have measured here where this rod is, down low where this rod is, and over here where that rod is. This one is shifted this way, basically a 1/16 of an inch, while that's threaded in. So I need to simulate that while this thing's under tension, and I can do that by tightening the threads on this rod to squeeze that a little bit more and get this plate in the right position. So theoretically, it'll thread in. That's the plan. Let's give it a try. So let me get a little bit of pressure on it, and then I'm going to do some measurements. So I compressed the spring and then adjusted each rod to get it to the same measurements that I was getting when the spring wasn't there and it was threaded in. According to my measurements, that should be it, for what that's worth. And now I compress the spring the rest of the way, far enough that I should be able to thread the bolt in. You metric guys are going to love this, but this is 37 and 15/16. So this should be 37 and 7/8, and I'm a little bit smaller than that. I'm almost a 1/16 small than 7/8, if that makes any sense. Probably doesn't. And this is also 15/16. So I may need to open this one up just a hair, but let's see if the bolt will thread on. Here I'm aligning the bolt with the nut. So now if I hold pressure on it, keep pushing it against the threads and go backwards, I should feel it clunk when the threads line up. I don't know if that was it or not. What is going on here? It's tight going backwards. Yep. This needs to shift that way. The socket is no longer rubbing against the end plate, so that's something. I do need to line up the bolt again, though. Let's try again. It might be working. I think it's going in. Holy moly. Oh. Thank goodness. Whew. All right. So I just screwed it in, and yeah, it looks like it went in about 1/2 inch. That's what it should. So now I can compress a little more, and that should get loose again. Let's see. 5 pumps there. What's that equal here? Yep. 4 ratchets. 5 pumps to 4 ratchets. See, now I've got that bolt in there. So this whole thing just became a lot less sketchy, because the bolt is going to prevent that spring from going back to its resting position. 1/8 of an inch at a time. 1/8 of an inch is about 3 millimeters. So I'll tell you, I may not do the full 4 inches. I may leave a 1/4 inch. That way I'll have an area to weld. I do believe that's it. But there you can see I've got 36 3/4. That's just under 4 inches. And I'm happy with that. I want an area to weld it anyway. I'd rather not have to grind it back and then weld it. So I'll just leave it there. I think that's certainly going to be adequate. So let me take the pressure off. Yeah. So now the bolt's got it. And I guess to be on the safe side, what I will do is I'm going to loosen off these nuts. Which nuts? These nuts. These nuts right here. Let it sit for a little while. Just make sure there's no issues with the bolt holding that spring tension. There certainly shouldn't be, but just for peace of mind, it won't hurt anything. I'm not in a big hurry. Wow, they're already loose. In retrospect, anyone doing this, this crazy thing in the future, put the bolt in with the end plate, with both sides, without the spring, and measure the distances so that you know you've got it lined up right so that the threads will mesh. You know, I had it lined up so the measurements were all equal and I couldn't thread it on. And that's because, for whatever reason, I needed another 1/16 of an inch in this one spot. Crazy. But that made all the difference. And knowing what I know now, how precise this needed to be to get that bolt to thread in, I think there is very little chance that you would be able to do this, squeezing this with the excavator bucket or against the ground. I think your chances of success would be very low, and your chance of an accident would be very high.
Later.
And there you can see the bolt actually, there's a little bit of a dish out right there. So there is room for me to put a little weld around that. Make sure it doesn't unscrew. That would stink. With the 4140 being what it is, I seriously doubt that thing would unscrew even if I just left it alone. That thing would gall like crazy under this much tension. Just a little more for me to do. This is the one that's not compressed as much as I would like. I'm gonna grind that off and then put some weld on it. So I thought about just putting a tack or two so this could be taken apart, but those threads are all messed up anyway. The only way you're getting this apart is cutting that bolt and drilling that out. So I'm going to go ahead and just weld it up. You know, the threads are messed up anyway, so this will give it a little extra strength. All right, that is all below the surface, so the track adjuster will be pushing out here on the plate and not directly on the bolt. So the next one, I'll grind a little bit. I'll get that center nipple off of there. And same thing, I'm gonna weld that one all the way up. The threads are a little messed up in there. This will add additional strength. And the way I see it, the only way this one's ever coming apart is if it breaks, because it's properly tensioned. And there's just no reason that I'm gonna wanna unthread that bolt, ever. Well, there you go, guys. The springs are finally done. Goodness gracious. This job was so much harder and so much more time consuming than I was expecting. I mean, everything always takes longer than you expect. This one, wow. What can I say? I learned some hard lessons, and this thing really ran me in circles. But we finally got there, I guess good enough. You can kind of tell which one is compressed more. If I have any problems with this one not being compressed enough, I have the tools now and the ability to fix it without too much awful trouble, I guess. But I don't think it's going to be an issue. But the track adjuster job continues. I still need to install the seals. I need to finish honing out the other grease cylinder. I need to reinstall everything, put the tracks back together, get the pin back in, and track plates, the whole shebang. There's a lot more that needs to happen, and that's going to be the next video you see on Large Marge. So thanks for watching, guys. We'll see you on the next one.